So it's time to take the level of interactivity of our programs one step further. In the past, the only form of interactivity we had with the user was basically variables, which could just control a little bit of the data. But all that did was change simple calculations, nothing too major within the program actions itself. The program still functioned exactly the same no matter what. The only thing that modified was the final result. What we want to do is modify the whole flow of the program. Now, if you look at the screen here, up till now, we've been working with this simple sequence structure. That's my mouse. We've been working with this simple sequence structure. It just flows from top to bottom. Now, recently, we've added in subprograms, which allow us to kind of jump out, do some actions, and then come back in. And we can have as many subprograms as we want, and we can go back to the same subprogram multiple times within the program. What we want to do today is expand upon this idea of the flow of the program. We want to be able to modify and change the whole outcome. We want to be able to execute some code and skip other code based on certain data, what's going on in the program right now. So this is our basic structure. Our first lesson we're going to be looking at is something that's going to do this. We're going to take a point, we're going to break out, we're going to do some code, and we're going to come back. You'll notice that we're going to skip some chunks of the code, though. We're going to do something completely different. We're going to go out and go along another path. Now, what's happening here is we're starting to control the flow of the program. Think of it like a fork in the road. The best analogy I can come up with is a train on a set of tracks. A train can flow down the tracks, and when it gets to one of these forks in the road, it has to choose either left or right. If it chooses left, and it goes down that path, imagine the train's coming here, so this would be left for it. It actually is stuck on that path now. It's not like it can backtrack. It's a train. Trains go forward, and then they come back, and eventually they're going to make it back to the tracks again. But that's all that's happening. It's coming down and it makes a choice. It's either going to continue on the path or it's going to go left in this case. Later, we're going to take this idea and expand upon it further. And we're going to allow two choices without a standard path. It has to take one of the paths. It either takes the left, or it takes the right. So it's going to flow along the path. Even later after that, what we're going to do is we're going to add a point where it can take an infinite number of options. And who knows which one it's going to end up with, but eventually it will end up back on the original path again. I'm not going to draw all these in here, but you get the general idea. So these flows, the flow of the program we see is actually changing, and it's changing based on data. So what happens is our code gets to a certain point and it makes a decision of a path to take based on the current value of some data, whatever that data is. Pardon me. So in order to do this, we're going to learn a new thing today, something called a control structure. And a control structure is a programming term that allows us to modify the flow of the program. So today we're looking at something called an if statement. An if statement, it is a more specific terminology for something called a selection statement, selecting a path within our program. So the selection statement or the if statements are going to allow us to make today one choice. It's either going to take the path or it's going to continue on with the standard program. Or two choices. It's going to go left or it's going to go right. Or 3+ / infinite choices. Now this is going to be something for a later module, but for today we're going to focus on these two right here. Pardon my amazing circle here. So what we're going to look at from here is how we actually make the choices. To do this, we need to understand how the program makes its choices. It does a comparison of data. It looks at values and says, hey, should I take this option or should I not? It's like when you get up in the morning and you hear your alarm go off. You decide based on how tired you are, should I hit the snooze or should I get up? All of our decisions in life are based on some form of data. Should I or shouldn't I? Should I go outside and play soccer? Well, is it warm outside? Is it rainy outside? All these factors allow me to make my choices. And we're going to do that within our programs today. Now, in order to do this, we need to know how to compare data. So we're going to use some new operators to do this. Now over here, I'm just going to kind of delete everything. And we're going to create something a little bit more interesting here. I'm going to add in a table. And actually, we'll just skip that table. And we'll just do it manually. So, let me go back over here. Take away this. Alright. So imagine when we want to compare certain data, we're going to look at a number of operators. Now we know some mathematical operators within programming, and these mathematical operators are things like plus, minus, divide, multiply, modulus, and that's great to do those kind of operations. Arithmetic. Now what we're going to do is we're going to be comparing, so we need to know some comparison data. So for all of our examples here, I want you to make some assumptions. I want you to assume that there's a variable called x, which has the value 5. And there's another variable called name, which has the value Bob. And this allows us to make some assumptions about the comparisons we're about to do. Now the first operator we're going to talk about is the double equal sign, also known as the equal to operator. This allows us to compare two numbers. Is the left side equal to the right? True or false? It's a yes or no question. So for example, we might say, is x equal to 5? And of course, that would result in a true. It is equal to 5. We see that up in our assumptions up at the top here. Let's just write this so we understand what's going on here. So our first operator is equal to. So that compares numbers. Numbers only. Now sometimes we need to compare strings. Now there is a problem in Java. Java doesn't handle strings the same way it handles other primitive values. So using the equal sign in Java will work in some cases on strings, but not all cases. So in order to make it work on all cases, instead of using equals for strings, we're actually going to use a function called dot equals. So in order to use this, so this is also an equal to operation, but for strings. So for example, I could say is name dot equals to Fred. And that will return me either a true or false. Well, Fred does not equal the value of name, which is Bob. So that's going to give me a false. So dot equals is the command that we're looking for. Sorry about that little red underline there. But dot equals, name dot equals. So the string, the variable that you have, dot equals, and then inside the brackets, whatever value you're trying to compare it against. Maybe that's a literal value like I have here, Fred. Maybe it's another variable. Maybe it's a subprogram call. Or maybe it's the input that the user's entering in, input.nextLine. It could be any number of things as long as it is a string that you're comparing against. So those are our equals operations. The next operation is the not equal. So not equal to. So again, this is for numbers. And we can check to see whether is the left is not equal to the right. So I could say, is x not equal to 8? Is that true or false? Is that statement true or false? Well, x is a 5, so 5 not equal to 8. Well, that's true. Oops. 5 is definitely not equal to 8, so that's going to give me a true. The next operator we're going to look at is we're going to get into some mathematical comparison operators. Greater than. Oops, don't do that. Autocorrect. Greater than. And of course, this is definitely a numerical thing again. So I could say, is x greater than 8? Well, x has a value of 5, so that's definitely a false. Less than. Is x less than 8? Well, x is 5 again, so yes, that is a true. And then we get into the next one. Now we can start to combine these two things. We can have greater than or equal to. Greater than or equal to. If you ever forget which order these two symbols go in, the greater than sign followed by the equal sign, just write it the same way you speak it. Greater than or equal to. So the greater than comes first, then the equal sign. So greater than or equal to. So I could say, is x greater than or equal to 8? Well, looking at this, x is not greater than. X is 5. 5 is not greater than 8. However, it is equal to 8. So this whole statement itself will result in a true. Similarly, less than or equal to x is, x is less than or equal to 8. Again, it's written exactly the way that we say it. X is a value of 5, which is less than 8. It's not equal to, but it is less than. So this statement will result in a true as well. So we ended up with 2 trues for that comparison statement. All right. Oh, sorry. The previous one, x is greater than or equal to 8, that is definitely false. I apologize. 5 is not greater than 8, and 5 is not equal to 8, so that should be a false. I apologize. So these are all of our comparison operators that we have. We can use these in any combination, and all we're doing is we're saying, is this statement true or false? So that statement, that comparison statement, evaluates to either a true or false. And we're going to use this comparison to choose our paths that our programs are going to flow on from here on out. So the next video will cover how to actually do that.